So first of all, thank you all for your love to this channel, and welcome back to one more topic, that is how this vacuum potential controls work function. So in this lecture, we are dealing with the topic how this vacuum potential controls the work function. So we will going to use this what is this vacuum potential is, and then what is that work function, and how we can calculate this work function by using SIESTA, because this all these and sensations are related to SIESTA. So we will use SIESTA to calculate this work function. So the first question is what is this vacuum level potential? And this vacuum level potential in a slave especially refers to the energy of the free electrons situated in the perfect vacuum, and it's far away from any material influence. This concept is crucial in the surface science, material physics, and particularly when we analyzing that electronic properties of thin films and the slab. In practical terms, it can be approximated as the point in the space where the electron experiences no electric field due to the material. And this level serves as the reference point for the measuring other energy levels within the material, such as the Fermi level and the work function. So the measurement of this vacuum level potential. So to compute this vacuum potential in the slab, this DFT is employed oftenly, and process generally include the setting of the slab with sufficient vacuum space, and that vacuum space is from 8 to 12 angstrom, and then perform that DFT calculation to obtain the electronic structure of the slab, and which involves this Hartree and ionic potential. And then this vacuum potential is determined by averaging the electrostatic potential across the regime in the vacuum. So this is the simple one. And this work function, we all, this is a very simple term, the work function. This is defined as the energy required to move an electron from the Fermi level to the vacuum level, and it is critical for the application in the electronics and the material science. So this is that minimum energy required to one electron from the surface of any metal. And here in this case we are talking about that the slab surface. And mathematically this work function is defined as phi, that is equivalent to E vacuum minus EF. This is Fermi energy level, and this is that energy related to that vacuum level. So schematically we can show this is that plot of electrostatic potential. So here this level, it is known as Fermi energy level, and this is now the vacuum level, and this gap, this is that the work function, and this is the representation of slab, and this is the vacuum one. So here we will find that that work function of this slab. So let's begin the calculation. So here, in order to calculate this, I have created that slab like a structure. So this is that slab of silicon, and that vacuum is created here, and then I have created that input file, and that is my, so this is that slab of this SI, and here I have added some lines like electrostatic potential true, because we have to calculate that vacuum potential, and there also I have added that border charge and that total potential. So these are some additional lines added in my template of that FDF file. So after running SIESTA, so how to run that, everything you know, but after running SIESTA, this will create some NC files which we have visualized by using that PhonoPy. So that, let me show you that result file where this vacuum potential is given. So that result dot out. So at the end of this, result file, this line is given. So this is the vacuum level, maximum and minimum, mean value. So we can take this mean value as a vacuum potential, and that Fermi energy level we have also mentioned here. So this Fermi energy level is it should be mentioned anyway. So that Fermi energy level we can directly calculate from our EIZ file. So that is this EIZ file. So here this is Fermi energy level. So it's about minus 5031. So this is 5032 we can take. So by using calculator, simply we can calculate. So here this is 5.032 minus this result dot out. This is that mean value. So with that and paste here. Yeah. So this is that work function of that silicon slab 4.6671. So I think let me check work function of silicon. Yeah, it's about 4.8 electron volt. It's given, and here we are getting 4.66 anyway. So minute difference is there. So thank you all, and calculate yourself the work function of different slabs.